Hello, and welcome to a micro tutoring session from Prep Plus. Prep Plus micro tutoring sessions unlock the secrets to common math and physics exam and homework problems. Today's problem is a calculus problem in differentiation. So let's just get right to it. Suppose you have a calculus exam problem that asks you to calculate the derivative with respect to beta of beta raised to the x power. So let's write that down. So the problem is calculate the derivative with respect to beta of beta raised to the x power. So this looks a little goofy. I'm not used to seeing a derivative with respect to beta of something, but don't worry. This is a very straightforward derivative to calculate. So the first thing we recognize is this looks very unconventional. The conventional rules of taking derivatives of things raised to a power don't really apply. So what you want to think of is when you see an exponent, think exponent. And if you think exponents, you think logarithms. So let's take an aside and try to figure out a solution strategy for this problem. So let's just think on the side. And we know that from the laws of logarithms, beta, the logarithm of beta to the x is x times the logarithm of beta. Okay? So that means e raised to that logarithm is the thing that we're interested in. So that means beta to the x equals e. Let me just point out that these logarithms can be with respect to any base. It can be with respect to base 10, base 2, base e, whatever you want. I'm going to work with respect to base e. So beta to the x is e raised to the power logarithm of beta to the x, which is e raised to the power x times logarithm of beta. So all I've done is kind of scribble some notes on the side to figure out a solution strategy. And I've determined that the thing that we're interested in, beta to the x, can be written as e raised to the power x times log beta. So that's the end of our side. That's the end of the little notes that we've written on the side to figure out a solution strategy. So now let's just execute the strategy. So now this means the derivative with respect to beta of beta raised to the x is the derivative with respect to beta. Well, all we've done is rewrite beta to the x using exponents. Because remember, if you see exponents, think exponents. So e raised to the power x times log of beta. Okay, so now let's just differentiate this using the rules of taking exponents of powers of e. So this is, first of all, just take this whole thing, e x times log of beta times the derivative with respect to beta of x times log of beta. Okay, so far we have no funny business so far. Just taking the, we want to take this derivative, first take the exponent out, it's just a factor, times the derivative with respect to beta of this exponent. Okay, so now we look at this part right here and we see, we can just apply the product rule for derivatives here. And so the derivative, so first take the derivative with respect to beta of x and then multiply that by log beta and then plus x times the derivative with respect to beta of log beta. So now that first part, the derivative with respect to beta of x is 0. That's x, it's not beta. So its derivative with respect to beta is 0. Okay? E to the x times log beta times the derivative with respect to beta of x is 0 times log beta. All I'm doing is applying the product rule, plus x times the derivative with respect to beta of log beta is 1 over beta. Okay? Now we know what this is. E raised to the power x log beta is actually beta to the x. That's what we figured out on our aside. So this is beta raised to the x power times x over beta, which is, drum roll please, x times beta raised to the x minus 1. So there's our answer. The derivative of, with respect to beta, of beta raised to the x power is x times beta raised to the power x minus 1. So that's it for today's micro tutoring session from Prep Plus. Prep Plus is your online solution for customized tutoring in math and physics for high school and college. I'm Rodney Green, the president of Prep Plus, and I invite you to contact me to schedule a free consultation. Check out the website prepplusinc.com.